Good evening, and welcome to tonight's health segment. We're shedding light on a disease that's been around for centuries, yet continues to pose a serious threat in our part of the world. Leishmaniasis. What is it, and why should we care? Let's dive in. Leishmaniasis is a disease caused by microscopic parasites of the Leishmania genus, transmitted through the bite of infected sandflies. This ancient disease, with cases recorded as far back as 1500 BCE, manifests in three forms: cutaneous, mucocutaneous, and visceral, also known as kala azar. While the cutaneous form leads to skin ulcers, the visceral type can affect internal organs and turn deadly if untreated. But what's fueling this spread? Ecology holds the answer. Sandflies, the disease's primary vector, thrive in warm, humid climates and are closely tied to environmental changes like deforestation and urbanization. When humans encroach on these areas, encounters with infected hosts rise, increasing the risk of outbreaks. Climate change and global travel are also playing a significant role in expanding the disease's reach. Where did it all begin? Leishmaniasis has its roots in both the Old and New Worlds, with different species adapted to regions like Africa, the Americas, and the Middle East. Wild and domesticated animals, especially dogs, can act as a carrier or reservoir for the parasite. And yes, humans can be a part of this cycle as well, mainly in urban settings, making this a clear case of a zoonotic disease. So who's at risk? Communities in tropical and subtropical regions where healthcare and prevention are low bear the brunt of this disease, unfortunately. It's a silent epidemic in some parts of the world, but its effects are devastating. Now we'll go to our man Michael on the scene.
Thanks, Evan. As you can see, I've taken a trip out to an impacted region in Bihar, India, to gain a better understanding on the transmission of Leishmania. This environment acts as a breeding zone for the parasite, where society and nature are very much intertwined. Let's take a closer look at the mechanisms behind the transmission of Leishmania.
To better understand how Leishmania is able to cause disease, we begin by looking into the morphological phases it undergoes in the vector, a phlebotomid sandfly. This process happens in a series of stages, each one designed to help the parasite survive and eventually infect its next host. It all starts when a sandfly bites an infected mammal and sucks up a mastigotes. These are the parasite's non-motile intracellular forms. They are oval-shaped organisms that reside within the host macrophages. Inside the macrophages, they are well protected, but when the sandfly bites, its saw-like mouthparts create a small wound, releasing macrophages and mastigotes into the blood pool. Once inside the sandfly's gut, the mastigotes encounter lower temperatures and a higher pH. This triggers their transformation. In the sandfly's midgut, the mastigotes transform into procyclic promastigotes. They elongate into a spindle-like shape and grow a whip-like flagellum that allows them to swim freely. These parasites rapidly multiply, creating a large population within a protective structure called the peritrophic matrix. This matrix, made of chitin and proteins, surround the digested blood meal and act as both a barrier and a microenvironment for the parasites to thrive. After a few days, the parasites transition into nectominid promastigotes. At this stage, they grow longer and become highly motile, using their flagella to swim actively. The nectominids break out of the peritrophic matrix by secreting enzymes such as chitinases that dissolve the barrier. They migrate toward the anterior midgut, attaching to the gut lining through specialized surface molecules like lipophosphatoglycan. This adhesion is vital to avoid being expelled during the sandfly's digestive process. This phase ensures that the parasites establish themselves firmly within the sandfly's gut. Nectominids transform into leptominids. These are shorter, more compact forms focused on two essential tasks: replication and PSG secretion. As they continue to multiply, increasing the population, they produce promastigote secretory gel, a viscous substance that will later block the sandfly's gut and facilitate parasite transmission. Some of the leptominids will differentiate into haptominids. These parasites attach themselves to the cuticle-lined stomodial valve using specialized structures at the tips of their flagella, which expand into hemidesmosome-like attachments. They provide structural support for the PSG plug by acting as an anchor. While haptominids are not infective themselves, they play a crucial role in creating the conditions necessary for transmission. The parasites finally enter their last phase, the metacyclic promastogote phase, a highly infectious stage of the parasite. These metacyclic forms are uniquely adapted for transmission, with elongated lipophosphoglycan molecules on their surface. These elongated LPGs not only provide protection against complement-mediated lysis, but also enhance the parasite's ability to attach to host macrophages, facilitating their entry and survival. This stage ensures efficient invasion, marking the critical point where the parasite establishes a foothold in its mammalian host. Now that we've covered how Leishmania is transmitted with the aid of its vector, let's discuss its effects on the human body. When the sandfly bites, it regurgitates the Leishmania promastogotes into the host's skin, alongside saliva and promastogote secretory gel. These promastogotes immediately encounter the host complement system, a critical line of immune defense. The majority of the parasites are destroyed by complement-mediated lysis. This intense evolutionary pressure ensures that the surviving promastogotes are the best adapted, utilizing elongated LPG on their surface to protect against complement attack and facilitate attachment to host cells. Once attached, promastogotes are engulfed by macrophages. Inside the macrophage's phagolysosome, promastogotes transform into amastogotes, a stage optimized for survival and replication. The parasites now must suppress the immune response by interfering with macrophage signaling pathways. They inhibit the activation of nuclear factor kappa of activated B cells, reducing the production of pro-inflammatory cytokines like tumor necrosis factor alpha and interleukin 12, which are essential for activating T cells. Leishmania also promotes the release of anti-inflammatory molecules such as interleukin 10 and transforming growth factor beta, inducing a tolerating host response. As the amastogotes replicate within macrophages, the host cells rupture, releasing parasites into surrounding tissues. These parasites enter the bloodstream and lymphatic system, spreading to organs like the liver, spleen, and bone marrow. In the liver and spleen, Leishmania targets macrophages, causing organ enlargement and disrupting immune functions. In the bone marrow, the parasites impair blood cell production, leading to anemia and immunosuppression. The systemic dissemination of Leishmania creates a complex interplay of immune responses. Although elevated levels of molecules like transforming growth factor beta and interleukin 10 suppress inflammation locally, they paradoxically contribute to chronic low-grade inflammation systemically. This environment facilitates the parasite's persistence and immune evasion, ultimately resulting in the severe symptoms of visceral leishmaniasis, including fever, weight loss, and profound immunosuppression.
Thanks, Michael. It's very interesting. But you know what else is interesting? The recent activity of the disease has caused an outbreak of analysts all over the globe to take interest and dive into the subgroups of leishmaniasis, much like this example.
Hello everyone, it's me Safal Khandka. Today we are diving into the topic of leishmaniasis. Now let's go to the current infection rates worldwide. Here we have the region and the estimated cases. Pretty simple. South America 2 million cases, Asia 1 million cases, and Africa 500,000 cases. According to recent estimates from the World Health Organization, approximately 700,000 to 1 million new cases of leishmaniasis occur annually, with 20,000 to 30,000 deaths reported each year. These figures may be underreported due to limited surveillance in endemic regions. As well, the disease predominantly affects populations in poverty stricken areas with limited access to healthcare. Those people who don't have much healthcare provided to them or medications, proper facilities, they are mostly affected, because even though they are affected by these viruses, they can't get good medications and healthcare, due to which they have to lose their lives. And here we have age related differences. Leishmaniasis affects all age groups. It affects infants, it affects children's, it affects adult people as well. But some trends emerge based on the form of the disease. For instance, children are much vulnerable to visceral leishmaniasis in many endemic regions due to their weaker immune systems. On the other hand, cutaneous leishmaniasis often impacts adults who are more likely to work outdoors, increasing their exposure to infected sandflies as well. And here we have infants, childhood, and adult in the chart. So infants and childs are mostly they are affected because of their low immunity, whereas adults, they have higher chances of fighting this disease because of their higher immunity response towards this disease. And here we have geographic variations in prevalence. The distribution of leishmaniasis is highly uneven. The disease is endemic in over 90 countries, particularly in tropical and subtropical regions. And in the tropical and subtropical regions, there are mostly the number of sandflies are more in those areas, due to which there are high chances of leishmaniasis in those kind of areas. Visceral leishmaniasis is most prevalent in South Asia, East Africa, and Brazil, while cutaneous leishmaniasis is more common in parts of Middle East, North Africa, and South America. Geographic variation in disease burden is closely linked to the factors like sandfly habitats, climate, and socioeconomic conditions as well. And here we have population variation. Leishmaniasis affects marginalized populations, especially in rural areas and the places where there is poverty, malnutrition, poor housing, weak healthcare systems, that increase the risk and severity of the disease as well. And additionally, individuals with compromised immune systems, such as those living with HIV, are mostly particularly susceptible to severe forms of leishmaniasis. And here we have mentioned about all the genetic factors, behavioral factors, and socioeconomic factors, which includes the genetic differences of the populations, which cause to increase the susceptibility and disease progression. Behavioral factors like how is their lifestyle, and socioeconomic factors like poverty, lack of education, lack of awareness among the people. So basically, in summary, leishmaniasis is a global health challenge. Its violence from the parasite's ability to manipulate the immune system, targeting macrophages and causing severe symptoms in some cases. So the disease impact varies significantly based on the age, geography, and population factors, with the highest burden seen in vulnerable and communities. Understanding these factors and is essential for controlling this kind of disease in this and today's generation. Thank you for listening. I hope this information has been insightful.
Crazy stuff. Even influencers over the globe have started making videos to spread the awareness of the disease, much like this one.
Hello, my name is Diego, and what I want to talk about today is the prevention and treatment of leishmaniasis. Now, in order to prevent it, what we have to do is try to keep the vector away. So one of the ways that we can do is cutting down their breeding zone. Now, they breed in the neighborhood where there's a lot of trash or a lot of gardening. A gardening that is not well taken care of. So what we can do is take care of our gardens and stuff, and also if we have weed and stuff like that, we can cut those down so that our neighborhood is clean. Putting trashes in their designated place so that people can take care of, like the people assigned to take out the trash, they can do it and does not litter our surroundings. And the way that comes to your own household is, if you think you're infested with it, you can go ahead and use an insecticide which is going to kill all the vectors in your house. The insect that works as a vector, right? The other way is, if you do not have access to any of this, what you can do is you can have a bed net. A bed net is basically a protective net around your bed which protects you when you're sleeping. Now, when it comes to treatment of it, there's a wide variety of antiparasitics out there, but the most effective that is being researched on right now is naphthoquinones, basically a derivative of naphthoquinone, which is known to have a parasitic property because of its depolarization of the mitochondria of the parasite. So that's the most effective one right now. However, there are more ways, such as intramuscular injections and IVIGs. So those are the ways that we can actually help treat the disease.
And with that, we conclude our health segment. Thank you for your attention, and we'll see you next week.